Now we talk about the zero order absorption model by the first order absorption. See, for um, for a drug absorption, as in the case of several by first order absorption process, it gets distributed in the body according to the one compartment kinetics and is eliminated by a first order process. So this model can be depicted as follows, that is, the drug at EV site will go from there the first order absorption, blood and other body tissue, and then it will be eliminated. So the differential form of that equation will result is dx by dt is equal to kxa minus kex. This is the differential form equation 9.46a. We have differentiated this equation. This equation has been differentiated into this form. So integrated that form, we got x is equal to, and when we talks about the concentration, the equation changes into the equation number 7. So we have to assess the following parameter, that is C max, T max. C is the concentration maximum and T is the time at which the concentration of the drug is maximum in the plasma, is called T max. So at a peak plasma concentration, the rate of absorption is equal to rate of elimination. So Kx is equal to minus Kex, and the rate of change in the plasma drug concentration denoted by dC by dt will become 0. So at this rate, we could differentiate the equation, this equation number 7, and that differentiation, after differentiating, that yields with the residual concentration, equation number 11 and 12. So absorption from this can be calculated as in the absence of plasma level time data. Useful information can be obtained from the urine method. So this method is useful for the urinary. We can use urinary excretion data if we doesn't want to use the plasma concentration measurement. So we can use this method when we have a lack of sufficiently sensitive analytical technique. It's a non-invasive, convenient, less sensitive, first order elimination, excretion and absorption rate constant, fraction excreted exchange can be computed from such data. Direct measurement of bioavailability, absolutely and relatively, as we told in the class, and when we coupled with the plasma level time, it can be used to estimate renal clearance of the unchanged drug. So there is a criteria for obtaining a valid urinary excretion data, and that criteria is that significant at least 10% of the drug should be remain unchanged in the urine. Analytical method specific होने चाहिए. Water loading should be done by taking 400 ml of the water and after fasting overnight. That will promote diuresis. Before administering the drug, the bladder must be emptying, and after 1 hour from the water loading, the first sample should be taken as a blank. Volunteers should be instructed to empty their bladder while collecting the urine samples. Frequent sampling should be done. During sampling, exact time and the volume of the urine excreted should be noted, and individual collection period should not be considered exceed 1 biological half-life of the drug, and should be ideally should be considerably less. Urine sample must be collected for at least 7 biological half-life in order to ensure collection of more than 99% of